So today we are going to be see about what are the architecture. So what are the architecture is provided by the Apache Pig. So in that, what are the phases are there? That phases how it is going to be deal one input, how it is going to be converted into a different forms. So even the MapReduce program is going to be take as input data sets. So before getting these data sets, how the data is going to be processed before submitting to MapReduce, how the data is going to be processed. So we know the difference why we are going with the thick Latin language. So it is easy to process, and the lines of code is very less compared to the Java language. If you write 200 lines of Java, then in Pig we can write only 10 lines of code is enough to express the same. So here this architecture, I think the architecture diagram also saw here. So here, please be remember, I will keep 1 or 2 minutes. If you want, you can try it, or else you can just Google it. You can get it. Pig architecture, Apache Pig architecture. You can get this. So here we have a Granite shell and Pig server, and these are the phases. So parser, optimizer, compiler, and execution. So if you want to know this, what is a parser, what is optimizer, what is a compiler, and what is an execution engine, predefinedly prerequisites we have to know about what are the phases of compiler, where we are going to be deal with these lexical analyzer, syntax analyzer, semantic analyzer, intermediate code generation, code optimization, and assembly code, how we are going to be generated. So simple, if one program we are writing in any language, how the compiler is going to be processed and submit to the low end, and how it is going to be get back. So can anyone say that what is the definition of a compiler? Definition of compiler. What is compiler? Please, can anyone? What is the definition of compiler? So ask them to join immediately. Only 27 are there. The remaining so many 60 members are there. Ask them to join immediately. Okay. So can anyone say that what is the definition of compiler? So generally we used to say that compiler converts from high level language to low level language. There we can add vice versa. So because our program input we are going to be given as a high level language, again we are going to get as output as a high level language. We are not going to be get any low level language. So we are going to be given a high level language, high level commands to the compiler. The compiler converts these high level language input is going to be converted into a low level language, then low level language to high level language. Even if, for example, so if you are typing something on printf, that the same thing is going to be shown in output. If you are entering a equal to 0, a equal to 10, and b equal to something 20, the final output is 30 is going to be given in decimal number only. It is not going to be given as a binary number. So such that we can define the compiler is converting from high level language to low level language, and low level language to high level language also. That is vice versa. So I think you are not gone through this compiler design subject, I think so. I think if you come across this PPL, programming, something programming is a PPL in second year, first sem or second sem, you have come across a PPL. In this subject, you may deal some of the topics out there, but in detail of compiler design, total phases, you are not yet come through. So I want to show that within 1 or 2 minutes. It's not only 1 or 2 minutes, it will take more time. So if you've gone through that, then we can easily understand how one programming language, how the data is going to be converting. So how the data is processing. So yesterday, while end of the class, I told you each and every time why I am inspecting one expression simply c equal to a plus b, how we are going to be processing it. And every time I am going to be say that an example as expression why I told you. So expression is the heart of the program. Expression is the heart of the program. So in order to process any program, so expression takes a major role. So expression only produce the result. So can anyone say that the definition of an expression? The combination of operators and operands which will give in a single value. Any expression we are processing that gives in a single value only. So that is the meaning here. So here we have same parser, optimizer, compiler, execution engine, map reduce. Then finally these processing data is produced in Hadoop. So if you remember the Hadoop architecture, the Apache Pig and Hive is the one of the part, and the lower level we have a data processing. For processing, again we are going to be build two parts. So mapper phase and reducer phase. One is the processing and one is dealing with the data. So if you remember, you can remember, or else you can go through that previous slide. You can see that what is the architecture of Hadoop. You can remember that in one block the Apache Pig word. Okay. So this is the simple thing, and this one is Apache components. So first one we are seeing already the parser, how it will be parser. So there only I ask you what is the syntax. So script is going to be does type checking and other miscellaneous checks is going to be. The output of the parser will be a DAG, direct acyclic graph, which represents the big Latin statements, logical and statements and logical operators. So how we were written in a language, I think yesterday some of them answered very well. So I asked you some question whether if you change something state, something expression in a program, but even though your aim is do some other program, but it shows nothing error, it's going to be processed like that only. So for that somebody answered it's going to be checked, it is not going to be checked a logical errors, it's going to be checked a syntax errors. So that's only syntactically whether the program is correct or not is going to be checked by the compiler. Any compiler, any programming compiler is going to be checked by the syntax errors only. It is not going to be checked any logical errors. So logic what we are going to be right. So based upon the logic, the output is going to be displayed. So whether the output is correct or not, we have to decide and we have to change any logical operations or any loops or any statements or any conditions we have to change according to that. Okay. So in the DAG, the logical operators scripts are represented in the nodes and the data flows are represented as digits. So we want to know about what is the DAG representation. So yesterday we saw about also. So I think yesterday we stopped here. This is the one. So this is a simple expression is D equal to A plus B plus C. So if the D equal to A plus B plus C is there, so why you are divided into three different statements? So this is the very, very important thing is known about three address code. So if you want, you can note down, if you have a paper, you can note down three address code. So this is a major representation of compiler. In order to process any expression, compiler needs to do this. The whole expression is going to be divided into a three address code. So what is the meaning called three address code? What is the meaning called three address code? So before I need to explain this three address code, shall I ask you one question? For example, if I have the same thing, d equal to 1 plus 2 plus 3 is there, how we are going to be add this thing? How we are going to be add? For example, you don't know how to do the addition. What we can do? What you can do? Simply. So you can write 1, we can write 2, we can write 3. First we can do, first we can add 1 plus 2, again 3. Then we can do again 1 plus 3 plus 2. So that is, we can say 6. How you can say this one like this? How you can say like this? How? How it will be? One second. I think somebody is clicking the annotations or somebody is processing. That's when I'm sure. Each and every time it shows an error. Okay. So see this, how it will. So each and every time, if you take any operand, on operand only one operate process at a time. One operator. Please be know the difference between operator and operand. For example, here A and B are the operands and plus are the operator. So each and every time we can perform only one operator only. So D equal to 1 plus 2 plus 3 if I said. So what will we do the first? So first the first plus is going to be performed. So again there is a meaning called how the first plus is going to be happen. Or for example, if we have a different operators are there in expression. So again we have the presidency. Have you remember C presidency table? There we have brackets and flower braces and operators. If you come to operators, arithmetic operators, what is the arithmetic operators? The highest presidency and lowest presidency. So there is which operator has to execute first. We can know about the presidency. Based on the presidency, that operator will follow. But at a time, one operator only is to perform first. So that's why so the whole expression is going to be divided by 3 address code. So that means so maximum we are going to be perform one operation. So here the meaning is so maximum 3 operands will be used in one statement. Maximum 3 operands. See here, for example, here the T0 is an operand and A is an operand and B is an operand. Okay, so see here we have T is 1 second. So here the T0 is operand and A is operand and B is operand. So in one statement, if the expression is divided, so based upon the 3 address code, what is the meaning of 3 address code? Maximum it is 3 operands in one statement. So T0 is operand, A is operand and B is operand. So these the 3 operands we are going to be use maximum in one statement. So such that so D equal to A plus B plus C. First we are going to be doing A plus B, that I am going to be storing one temporary variable. So next I am going to be add these A plus B, that addition is contains in T0. Then we are going to be doing T1 equal to T0 plus C. I am going to be add the addition of A and B added to C. Now see the second statement also, it is also contains only 3 operands. So T1 is an operand, T0 is an operand, C is an operand. So 3 operands. The next what we are going to be do, so the total contains, maybe for example T0 and T1 contains the total that I am going to be assigned to the D. Total I am going to be assigned to the D. So such that the result I am going to be assigned to the D. So here also, here we have D, T0 and T1. Okay. So here I think we have a similar way of representing how the 3 address code. So see that if you want to draw a direct acyclic graph, I said this graph now, how we are going to be represent a graph can contains edges and nodes. No? So edges and nodes. So see that for example, you can take the first statement. So plus is a root node, plus is a root node, and leaf nodes are operands. A and B are the operands. So root node again it stores the result. So what is the how it will be stored the result? I will show you. Go back with it. See that. Read this last 3 lines. I am reading. Please be noted clearly. Leaf nodes as represented as an identifiers, and the names are constants. And the interior nodes represents an operators. Interior nodes represent operators. That is a plus or star or minus, what are that things is known as operators. Then interior nodes also represent the result of the expression. So this is the third one is the result of expression is also known by the root node itself. So that is the root node. So see here where the result of A plus B is contained. So A plus B is contained in the part of T0. Okay. In T0 we have A plus B value. So same way, if you draw like this is for example, T0 contains a value. This T0 total diagram I am going to be added to another plus operation. This, so these operation I am going to be, so I have a T0 and T1, and again I am going to be do the operation. I am going to be equal to this one. So I am going to be use this. Okay. So here not a plus, diagram is mistake. Here is equal. Okay. Please remember, here is a equal. Here is a equal. So equal to is also an assignment operator. So such that the DAG representation is done. So how this representation program is going to be done? So this is the duty of a compiler. So this is the duty of a compiler. So let me, I have one more diagram. So this just briefly I am going to be explain. I will send you this document if you prefer, if you want more. So okay. So this is the compiler. Compiler, what is going to be do is it is going to be translating programming language into a mission language. So that is the source language is going to be converted into a target language. So why compiler? Filling the gaps between the programmer and the computer hardware. So how it is going to be understood. So this is a simple diagram for a compiler. Source code is going to be converted into a target code. So if the compiler, what is the duty? It's going to error message. What type of error message means? Any syntactical errors are there in the program that is going to be shown. So in a programming language or formal specification, any specification is known as a source program, source code. Then the target code is again the programming language output. It shows as assembly mission code. So assembly mission code means, so you come across this microprocessor codes, add a comma b, subtract a comma b, immediate address mode. In CO, computer organization, you may learn about what is the indirect addressing mode, immediate addressing mode, how we are going to be represent the, how we are going to be performing assembly language code operations. So that is a, so then you know the difference between compiler and interpreter, line by line and page by page. It will take. So there is some of the difference between the compiler and interpreter. So, so this is the total layers of phases of compiler. So it is a similar like you come across the computer networks, no? So in computer networks we have the phases, no? Physical layer, data link layer, um, network layer, transport layer, session layer, and presentation layer and application. So how the data is processing, transfer. Same way, if you return something as a high level language code, that is a source code, if you return, how the target code, how the program is going to be processed on computer. So this is, so we have a lexical analyzer, syntax analyzer, and semantic analyzer, and intermediate code generation, and code optimization, and code generator. So these are the things we are going to be discussing. What is this intermediate code generation? Intermediate code generation is the meaning of the three address code. That is the three address code. So annotated tree that same how the direct cyclic graph now. That is same meaning here also. How we are going to be mentioning a tree manner if one expression is there. So in literal table and symbol table and error handling, these are predefined things. For example, if I am going to be write, if I am going to be use something symbol in a program, so how the symbol table is going to be. In simple meaning is, for example, if I written int a comma b comma c. So what is the meaning of int a comma b comma c? If I written in one programming line, what is the meaning? How you can understand that one? How we can understand that one? Post a message, ask them to join all of you. Only 39 were present. 39 out of me, 38. So post a message, ask them to join immediately. So how it will be? So how we are going to be transfer all those things here we can see. Okay. So what I asked, so if I am writing one statement int a comma b comma c in one line. What is the meaning? So a and b and c are identified as a integer variables. So it is a variables was identified. How it is a variable mean? What type of variables mean? It is an integer. Such that the symbol table is going to be allocate the space for that a and b c spaces. So what is the size of integer based upon the size? The symbol table is going to be allocated in memory. So that is a simple meaning. So if you deal in depth, you can learn all these things. So I don't want to go in depth. I want to show you how it is going to be processed. So even for example, this is a one programming line. So this is one programming line. So for example, you are going to be calculate the interest. Okay, how you are going to be write position equal to initial plus rate into 60. So this is the one expression is there. How the compiler is going to be do this expression evaluation. So because I need one answer, that answer in position I have. For example, initial some amount and interest rate something. I'm going to be multiply with the 60. And then how we are going to be transfer. So we have all these layers: lexical analyzer, syntax analyzer, and semantic analyzer, and intermediate code generation, code optimizer, and code generator. So what is the duty of lexical analyzer means? It is going to be identify the identifiers. So position, what type of identifier? Identifier 1, identifier 2, identifier 3, and this one 60. So as usual, constant values as usual. So what is this identifier? How it will be? Can anyone know that? Have you come across the flat subject, flat formal automata theory? What is a diagram? So you know that recognition token recognition is there, no? So we have diagrams are there, NAP and DAP diagrams. Have you remember? So we have a regular expression. Have you heard the word regular expression? Regular expression, NAP, DAP, formal automata, all those things. So where we have how to write and identify one identifier. So this what the duty of lexical element. It is going to be scan the input and it is going to be divided into a number of tokens. So this is known as a tokens. Then what is a syntax analyzer means? It is going to be do the parse tree, or we can call a syntax tree. What is syntax tree means? Syntax tree root nodes are contains operators and edge nodes are contains these tokens. What we identify now, the tokens means nothing but identifiers. So see that. So first operation is going to be star. Star is a root node and one leaf node has ID 3 and another leaf node is 6. So these total I am going to be add to the ID2. So that is a plus operation. Total this as a one node, one child, and another child as a ID2. ID2. Then these total I am going to be assigned to ID1. So that is a equal to I am going to be added to root node, and one child is this one, another child is this. So now the operation is going to be down to this way, and final answer is going to be stored. So how it will be, sir? Each and every equal to how it will be assigned means. Have you remember the that what I said now? Precedency table. In a precedency table, we have first one we have a token that is the operator. Second one we have what? So which order? And third one, have you remember the association? In the table third column we have association. What is the meaning called association? There we have left to right, right to left, left to right, right to left. Have you remember the words? So if you don't remember, please go through the table. See presidency table. You can type in Google. You will get the third column as left to right and right to left. So what is the meaning called left to right means? So these plus and remaining operators are going to be do. For example, a plus b means a and b is going to be added. So that is the left to right. And equal to means what is a c equal to a plus b means a plus b answer is going to be stored into c. This is right to left. So that is the meaning of association. Have you clear? C equal to a plus b if I said, A plus B is going to be left to right association. A is going to be added to B. Then C equal to A plus B means what is going to be get by C? A plus B addition value is going to be assigned to C. So that is a right to left. That is the meaning here. Then semantic analyzer means I already told you. So there is meaning of assigning a value if I'm going to be perform integer addition or integer subtraction. So here we don't know what is the ID3. If ID3 may integer or may real or anything, it may pull out value also. So based upon this consideration, I am going to be convert this integer value into a real value. So that is means 60 is going to be converted into a 60 points. So if it is done like this, then what is going to be? So it is whatever it may be the operation, the highest size of data type is real, such that the operation is going to be done in the real operation. So multiplication is going to be done as a real multiplication. So for that only, the semantic analyzer is going to be take place. So this is known as a type checking. This is the meaning known as type check. Then what is the intermediate code generator? See that we have these tree. Final, the output of semantic analyzer output is this one. This one, how it is going to be write it into three address code? What is the meaning of three address code? In every statement, there is maximum of three. Maximum. I don't say that. So every statement must contain three. It is not like that. Maximum of three. So see that first operation I am going to be perform into real of 60. So that I am going to be stored in a temporary variable one. Next, what I am going to do? Now this total value contains in temporary one. That I am going to be multiply with ID3. So ID3 into temporary one. That I am going to be storing temporary 2. So now I am going to be perform addition operation for this total value. This total value where it is available in temporary 2. So ID2 plus this total value is temporary 2. Now the temporary 3 contains the total answer that I am going to be assigned to ID1. So that's see ID1 is equal to 10. So this value is that. Now code optimization. Here it is reducing the number of steps from the three address code. So even if again the code optimization also contains the statements are in three address code only, but is there any chance of we can reduce the steps here? So such that see here, for example, instead of using a temporary three, directly we can write it here ID1. We can eliminate one more temporary value. And another one here temporary one is performing into real operation, so directly we can write it as 60.0. So that is a real operator. So if you perform like this also, the value is going to be 60.0. So this is known as a constant folding. If you gone through fully about this one, this topic known as constant folding. So instead of performing this one, for example, if you write any one statement in a programming language, for example, C equal to 10 plus 20, instead of writing any expression, we are going to be directly do the operation on constant values. C equal to 20 plus 30. So is that number of times program is good that the constant value is going to be changed? No. Why we want to give a burden to the compiler to perform each and every time that 20 plus 30? Then we can do the folding of that value, that is constant fold. So here also same thing. If the answer is that the expression itself contains the 60, the 60 value we are not going to be get from any others. The 60 value is a predefined value. So if you perform 60 value into real, if the 60 is going to be converted into 60.0. So in order to eliminate this line temporary variable 2, we can perform like this. So such type of optimization is going to be done by the code optimizer. Then another code generator means it is going to be assembly language. So for constant value, we are going to be use immediate addressing mode, hash symbol. If you remember addressing modes, immediate addressing mode, implied addressing mode, index addressing modes. This one. Move F, MOVF. This one means So we are going to be move id value to r2. Now we are going to be multiply with this constant value with r2. Then move f, what id2 value we are going to be move to r1. Then now add r2 plus r1. The final result contains in r1 only. Then move r1 comma id1. Then r1 value is going to be moved to id1. So this is a association again here. So always it is going to be moved from here to id3 values move to r2. These multiply 60 value multiply with r2 and the final result is going to be stored in r2. So if you remember this one, c equal to c plus a, for example c plus a. So if you expression is like that, we may write like this also, no? C plus c is equal to b. What type of operator this one? Can anyone remember? What type of operator this one?
Compound assignment, sir.
Yes.
Compound assignment, sir.
Assignments. So directly means that, so final result itself we are going to be storing the same variable itself. That means, so why we are going with in future we don't need of that c value further use. That's why we can directly do that. So for that we can reduce the number of temporary variables, or we can say that directly we can reduce the number of variables in an expression by using that one. Same here also. It is going to be id3 value is going to be assigned to r2 and 60 is going to be multiplied with r2 and result is contained same here. So the simple meaning is r2, if for example this one, r2 is equal to r2 into 60.3. The same thing everything. So this is a overview of the compiler design. So the remaining everything, if you write for example this is a one state program statement. So what are the input statements you can write in, for example in c, c++, java or anything. So what we have to write for the input statements for this, for example enter position, scanf you are going to be enter that one. Then enter the initial value. So for scanf you are going to be enter the initial value. So enter the rate. We are going to be enter the, by scanf you can enter this. So these are the printf, scanf, all those things are the predefined things. So printf is a predefined statement. Scanf is a predefined statement. Yes or no? If the predefined statements are there, so that is going to be noted by the compiler itself. So there what it is going to be checked means, if the printf is written in small letter or capital letter, if something is wrong, or printf not end with the semicolon, so such type of syntax errors is going to be checked by the compiler. But whole uh, process is going to be done at expression. So the initial values it has to take and rate values has to take and position. So sorry, I ask you enter the position. It is not enter. So we have the final answer. So the final answer, the position is. So we are going to be print the value. So such that this expression is going to be followed. So that's why I told you expression is the heart of the program. Any program, any programming language, expression is the heart of. So symbol table management, I told you every symbol, the variable name and procedure call are constant returns. Anything we have a record. So everything, what are the things we ever used, that one we are going to record. So this is a lexical analyzer. Simple, that diagram total I am going to be divided into each and every part. So this is the input. How the lexical analyzer is going to be do? It is going to be do the tokenization. So we have, I told you if you read any phases, you have to remember each phase functionality. If you take a physical layer in a networks, it is going to be a representation of it. Same here, the lexical analysis is going to be do the tokenization. It is going to be divided source program into token. Then syntax analyzer, it is going to be draw a structure. This is known as a syntax tree or pass tree we can call. So this is the predefined how the syntax tree. So sentence statement. So how we are going to be write the same thing. If, for example, I see plus the, so how the statement is going to be drawing. So how same way how the sentence is going to be expression is going to be draw as a past tree. Then syntax semantic analyzer. Is there any type checkings are there? So any values we need to constant values we need to change. So such type of type checking is going to be checked by the semantic analysis. So any type checking is used. Then intermediate code generation is going to be done with the three address code. So every one thing. So there is a three address code this one. So if the tree is confirmed from the tree, we are so I to R means int to real. The meaning is I to R means int to real. So three address code generation, syntax directed translation. Then code optimization is we have to reduce the number of steps from the three address code. So what are the maximum possibility of reducing the steps from the three address code? Then the code generation we have to write as a assembly language code. So this is a simple meaning of these compiler cases. Now we have an idea of what is a thing. So so know that what is a DAG, how to represent as and DAG, how we are going to be represent all this. Next, another one is about optimizer. The logical form DAG is processed into a logical optimizer which carries out the logical optimization such as projection and push down. So how we are going to be do the reducing. So how come we can reduce from the DAG such that a number of statements we can reduce. Then compiler compiles the what is the meaning of compiler and compiles? There is the two words different, only meaning changing by the R and S. What's the meaning of compiler and compiles? Compiler compiles the source code. Okay, in one statement we can define both. Compiler compiles the source program. So compiler is a, for example, you can say that compiler is a software. Compile is a process. Every source program is going to be compiled on compiler. So compiles the optimized logical plans into a series of map reduced job. So here we are going to be talking about uh, pig Latin pig Latin language is going to be used as an input to the map reduce. Then execution engine. These are the parts of this pig architecture. The final MapReduce jobs are submitted to Hadoop and in a sorted order. Finally, these MapReduce jobs are executed in Hadoop, producing the desired result. Producing the desired result. So this is a big Latin data model. The data model of big Latin is fully nested and it is allows to complex non-atomic data types such as map and tuples. It's given as a diagrammatical representation of big Latin data. So if the data is there, so total things in a total, for example, one Raju, 21 Hyderabad, total thing is going to be called as a tuple. So in a row wise is going to be called as a DAX, and we have each and everything is going to be called as a fields. So for example, this is a form of a data. These form of data, how these big Latin is going to be read it. Either maybe a tuple, either maybe a tag, either maybe a fields. How it is going to be called per process. So atom. What is an atom? Any single value in big Latin, irrespective of their data, the type is known as an atom. It is stored as a string and can be used as a string and number. Int, long, float, double, and char array and byte arrays are the atomic values of big. A piece of data or a simple atomic values is known as a big. For example, Raj are 30. are the fields. So these are the atoms. So in a fields in the diagram, if you remember the diagram, so these are the fields. So in a particular one particular part is known called as an atom. Atom means single one. One particular thing is known called as an atom. Okay. Then what is a tuple? The record that is formed by an ordered set of the field is known as a tuple. The fields can be any type. A tuple is a similar row in the table of RDBs, Relational Database Management Table. So one particular row is going to be called as a tuple. So for example, maybe any one of key by using you can represent. For example, the 30th row is Raju. His details is contained in this particular row. That the information is going to be shown in the one tuple. Then another one is about bag. What is a bag? A bag is an unordered set of tuples. In other words, a collection of tuples, non-unique. Definitely, it should not be unique. So such that only we are going to be having keys, the primary key or foreign key are going to be used to avoid the duplications. Is known as a bag. Each tuple can have any other of these flexible schemas. The bag is represented by braces, flower braces. It is similar to a table in RDBMS, but unlike a table in RDBMS, it is it is not necessary that every tuple contains the same number of fields or that the fields in the same position column have the same type. For example, see like how we are going to be mentioning as a bag. So in a bag, we are going to be mentioning a flower braces. So Raj 30 and Muhammad 40. We are going to be mentioning one. The bag can be a field in relation that contains it's known as an interior bag. So why we have mentioned the Raj 30 and Muhammad 40? There is a relationship between these two fields. What is Raj and what is 30? So there is a relationship that such that only we have make into another bracket. So these inside this thing is known as inner bracket. So that may be, for example, Raj 30 may contains such the details information. So for maybe we have his phone number and his email ID. So bag contains another inner bracket. The bag may contains another inner flower basis that is known as inner bags. So then another one is about, you know what is map? The map or a data map, a set of key value pairs. It has a set of key value pairs. The key is needed to be a char array and should be unique. The value must be any type. It is represented in the normal square bracket. So bag is going to be represented in flower braces and the map is going to be represented in square brackets. Example, name Raj and age 30. So one is known as a key, another one is known as a value. So which one is, so again, there is a restriction. The key should be unique one. A key need to be type of char array and should be a unique. So unique values needs to represent as a keys. And the values of any type, it must be represented inside the. So in between relationship, a relationship is a bag of tuples. The relationship in Pig Latin are unordered. There is no guarantee that the tuples are processed in a particular order. So any order of any order, the data may going to be processed. Any order, the data may going to be processed. So such that the relationships are going to be okay. So I'm going to be stop up to the here. So these execution modes we will discuss tomorrow. Today we saw about Apache pig architecture. In the architecture we have what is the first two we have shell models, grand shell. That is the execution engines. Tomorrow we will discuss about that one. And the down we have phaser, optimizer, compiler, and execution engine. Even if execution engine also we will discuss tomorrow. So that phases are there. So what is the phases? how the data is going to be converted into a tag, direct acyclic graph. So how we are going to be use the direct acyclic graph as per an expression. For that prerequisite, how the compiler is going to be converting from high level language to low level language and low level language to high level language. How it is going to be, how we are going to be process everything beside. So how the data is going to be processed, how the expression is going to be divided into a tokenization, pass tree, syntax tree, and three address code, optimization, and assembly language, how we are going to do everything we saw. So still now anyone having doubt? So please be very clarity on these topics. This is a very useful topics, compiler design. So how this direct acyclic graph we are going to be drawing. So these are the important naming in how we are going to be drawing direct acyclic graph. It's a very, very important term in interviews also. What is a direct acyclic graph? So why we are going to be mentioning? So leaf nodes and root node are there. So what are the things we are going to be representing leaf node? What are the things we are going to be representing root node? Leaf nodes are represented as identifiers. Root nodes are contains operators. And even if leaf nodes beside we are going to be write something that it gives the interior nodes operation result. It also we are going to be shown in the figure itself. So that is the need of direct acyclic graphs. DAG, D-A-G. So anyone having doubt can ask me. Anyone having doubt? Just tell me anyone having doubt. Okay. Anyone? Still anyone? It's number 70. Chapani.